So good morning everyone. So today we'll start chapter number 5. So this is about continuous random variables, like how much time people spend on, let's say, social media. Or it could be at what speed a car is going on a freeway. So if that is a random variable, it's going to be a continuous one. Battery life of an electric vehicle. So once you charge, like how much life it has and how much it changes like every time you charge. So that could be a continuous variable. There are 3 statistical distributions that we look at for continuous random variables. One is called uniform. And the shape of uniform distribution is something like this. You have a random variable x, and then you have on the y-axis f of x, which is probability. So the idea is that probability remains constant. So it could be from here, somewhere here to here. The value remains same, flat. Another distribution that we will look at is exponential. So once again, if you make a picture with x and f of x, this distribution is going to look like this. So probabilities start at like high values and it keeps on reducing. So this is like right-tailed or right-skewed distribution, because the tail goes longer on the right side. So we'll cover that in this chapter, and then we'll continue with random variables which are continuous in chapter 6 and focus on normal distribution. The shape of normal distribution, if you have x and f of x, so normal distribution something like this. It is a symmetric distribution. It has high probability in the middle, and then slowly it reduces. Now, one unique thing about continuous random variables is if it is a random variable that captures speed of a car. So what is the probability that x is equal to 65? 65 miles per hour. Exactly 65 miles per hour. So that probability is about approximately 0. So we never calculate probability of a continuous random variable exactly at a value, because it is going to be 0. And the reason is, if you think about how many values exist between, let's say, 65 and 66. If a car is moving at like some speed and you find like what is the speed of the car in terms of miles per hour, how many values we can get between 65 and 66 miles per hour? 100 values. So if you are able to measure 65.01, 65.02, and so on, you may get 100 values. 2 decimals will give you 100 values. But what if you are able to measure up to 3 decimals? That is also possible. It depends on like how accurate your measuring instrument is. So you may be able to get 65.001, 65.002, and then you get 1000 values between these 2 numbers. If you are able to measure 4 decimals, then you get 10,000. 5 decimals, you get like 10 times more. So there's no end to like how many values you can get, because it totally depends on what measuring instrument you are using. And as I mentioned earlier, all these data are just a representation of reality. It's an approximation of reality, they are not reality. Even if you get 65.001 as a speed, if you measure more accurately, maybe it is slightly different. So theoretically, you can get infinite values between 65 and 66, because you can go to so many decimals. After some point, it may be meaningless. It may not be adding much value, but theoretically you can go. So you may be able to get infinite possible different values between 65 and 66. And if you start attaching even a small probability, very, very small probability to each one of them, so total probability is only 1. You cannot go beyond 1. So that's why at any single value, the probability is 0 for continuous random variables, because theoretically you have infinite number of values between any 2 points. So we never calculate what is the probability that x is equal to something. So that we were doing with the discrete random variables, but with continuous random variables we don't do that. What we do is we calculate area under the curve. So to capture probability, we try to capture what is area under the curve. If you look at the first distribution, uniform, so this is how it looks. So I made this picture earlier also, so same thing. So x, and then you have f of x, or the probability on the y-axis. And if you pick up like any 2 points, let's say this is A and this is B. So between 2 points of interest, if probability is exactly same. So for these situations, we say f of x such that, so if x lies between A and B, so fx is given by that. For uniform distributions, mean is given by mean equals a plus b divided by 2. Basically midpoint. It's a rectangle. If you look at this picture, it's a rectangle, and mean is at the middle, so that is a plus b by 2. Standard deviation for uniform distribution is given by, it is going to be square root of b minus a whole square divided by 12. It's not very difficult to derive these formulae, because the shape is very simple. It's a rectangle, and what you need is length and height. So once you have that, you can figure out things very easily. Now, how do we calculate probabilities? So for that, I'm going to write down 3 situations. So if we are calculating, let's say, probability of x less than equal to some value small x, so the function that we use in R, you'll see P and then UNIF for uniform. And then you put X, A, and B. Probability that X is greater than small x, which is upper tail. Earlier also we used a similar format. The only thing is we have to say lower tail is false. Pth percentile. So you are given the area and then you want to figure out what is the value of x. So you are doing some kind of inverse calculation. There we use Q uniform or UNIF. Q for quantiles, and then you can put this Pth and then AB. So we should be able to solve any problem using these 3 situations. Example 5.2 from the book. The amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes. A is what is the probability that a person waits less than 12.5 minutes. So it's always a good idea to create a picture. So in this example, we have a random variable x that follows uniform distribution with A 0 and B 15. What is the probability that x is less than 12.5? And we are interested in this area. So sometimes, like when you are working on a problem and if you are doing a quiz, you may not require any calculation. If a question is asked in this situation, is this probability more than 0.5? You don't have to do any calculation. You just see visually that area is more than 50%. So obviously probability has to be more than 0.5. So even without solving some of the quiz questions, you may be able to answer just looking at the picture. So for this one, I'm going to input P UNIF 12.5, A is 0, and then you have 15. So Posit Cloud. So I'm going to clean this up. And going to File, I will open a new file, and then I will save this as chapter 5, just like I have saved chapters 2 and 4, chapter 5. So once you do that, you'll see that chapter 5 is now available under Files. And it will be there, like whatever you do now will automatically get saved from time to time. So this is going to be chapter number 5. We want area to the left of 12.5, so P UNI, and as you start typing, it brings this function up and also gives you some information about what distribution that is. So select and simply enter what you need. A is 0, B is 15. So that is 83%. And we saw that picture, definitely it was more than 50%. So more accurate probability is 0.83. So the question was, what is the probability that a person waits for the bus less than 12.5 minutes? And the probability is 0.83. So that is A. Now let's look at B. On an average, how long must a person wait? In that sentence itself, it is telling you to find average. It is asking what is the average. And you know, like the formula I gave you for average, it is A plus B by 2. So A is 0, B is 15. So 0 plus 15 is 15 divided by 2, 7.5. So that's how you get average of 7.5. So average is 7.5, and what is standard deviation? So once again, standard deviation is given by this, B minus A whole square by 12 square root. So this was A. And for standard deviation, we saw the formula is square root of B minus A whole square. So 15 square basically. So 15 square divided by 12. So 4.3 minutes, that was the standard deviation. Part C says 90% of the time, the time a person must wait falls below this value. So when you make that picture, area to the left is given as 0.9. Now area is given, or the probability is given, and we have to find what is the value of x. So that is your third situation, pth percentile. So I'm going to use that formula, QUNIF, and 0.9, 0 is A, 15 is B, and the answer is 13.5. So this is your part C. Suppose that a value of stock varies each day from 16 to 25 with a uniform distribution. So during a given time period, a week or maybe few weeks, it is varying like a uniform distribution. Find the probability that the value of stock is more than 19. We are given a random variable x that follows uniform distribution with A as 16 and B as 25. So that is given. Part A says, what is P of x more than 19. We make this picture. So area to the right. So we are interested in that area. Now before we solve this problem, a quiz question may be, what is the probability that x is less than 16? What is the probability that x is less than 16? So how much is that value? Yeah, 0. So anything below 16 is 0. Anything above 25 is 0. Everything is in between. Less than 16 and more than 25 is going to be 0. Now how much is this value? This line here, what is that number which remains same between 16 and 25? 1 divided by b minus a. So this number is 1 divided by b minus a. So 25 minus 16 is how much? 9, right? So this is 1 divided by 9. So we are on the right side. We are not in the lower tail. So lower tail should be false. So when you input p, u, n, I, f, and this 19, and then this a, and then 25, and then you have to say lower tail is equal to f. So that should give you 0.667. There is 66% chance that the stock price will be between 19 and 25. Part B is find the probability that the value of the stock is between 19 and 22. So now you have a range. So this is going to look like this. So you have 16, 25, and we are interested in this part. How to find this area in the middle? If you find area to the left of 22, it will also include this area. That could be one way. You find area to the left of 22, which is up to this, and then you find area to the left of 19, which is this part. So you are taking that out, and you are left with middle part. We will write this as P, U, N, I, F, and the larger number first, so 22, and then AB, 16 and 25, minus P, and then you have 19, 16, 25. So that should give you 0.333. Let's look at part C. Given that the stock is greater than, now there is a small twist to the situations we have seen in this problem. It says given that the stock price is greater than 18, what is the probability that stock is more than 21? So it is saying that we already have a knowledge that it is more than 18, then find the probability. So the way we are going to write this is, so we are interested in, as per C, what is the probability that it's more than 21, given that it is more than 18. So for that we use this symbol, this vertical line, and capture whatever is given. So this stands for given that. So what is the probability of x more than 21 given that x is more than 18? What we do here is our picture changes slightly, and earlier the value started from 16, went up to 25. Now if we are given that 18, it is more than 18, then the values below 18 become 0. So now we start at 18 and go up to 25. So obviously distribution changes, parameters change, the value of A changes, but approach is similar. Now we are interested in area to the right of 21. And if you apply the formula, so this will be your R function, that will give 0.571.
Incoming rate
For next Tuesday.
for next.
Due to some reason like